Okay, we're going to look at now a second or more complex method for calculating the average or the mean, and I'll refer to this sometimes as method B, or it's the weighted method. So we'll use this in the case of a quantitative variable that's continuous. We're looking at the first moment, so it's looking at the central tendency. In a previous class, several years ago, I asked students to go down to the cafeteria and collect data on the heights of women. And so what I did is I gave them 6 categories from 55 to 73 inches. And I said to count the number of women in these various height categories. So for example, they used this system where somebody would say 65 inches, they would mark it like this. Somebody that was 70 inches, 71 inches would be like this, and so on and so forth. 1, 2, 3, 4, 5. And they brought the data back to me. Now, you might ask the first question, well, what happens if somebody is exactly, let's say, 58 inches tall? What category to put them in? And I want to clarify this a little bit, is that nobody is exactly in at 61 inches, for example, because literally that would mean that they're 61.0000, and at some point there's going to be a digit 1, 2, or a little bit below, so it'd be like 60.999, something like that. And this has to do with the idea that it's a continuous variable. Now, in practical fact, what I asked the students to do is if they thought somebody was at say 67 inches, kind of make a quick guess as whether they're above 67 or below 67. But this is a very important concept, is that somebody, in the case of a continuous variable, you cannot be exactly some number, and it has to do with the real number line. We'll look at this later when we look at this question of probability. They say everybody is a little bit above or a little bit below. In any case, the students came back, and this is the data that they presented to me. So we can see that in total, there were 200 students measured. These were all women, and there's about 2 that were between 55 and 58 inches. The bulk of students were around 61 to 67, something like that. There were a couple of the very tall basketball players that are above 70 inches, 4 out of the 200. So I've written the data here, and this is quite relevant. We'll be using this data as we go through the course. I've just presented it in a different way, but you'll notice now I've called this absolute frequency, and this is the term that's used for it. Absolute frequency, the number of people that fall into each of these categories. Bear in mind too that I didn't have the exact data. For example, the 2 women that were between 55 and 58 inches, I did not have the exact data how tall they were. All I knew is there were 2 women that fell into this category. Incidentally, this word category is sometimes referred to as a cell. So my best guess of those 2 women, how tall they are, well, it would be the midpoint value between 55 and 58, and that's what I've drawn here. So, for example, the same thing. Those between 61 and 64, there were 74 students like that. I didn't know how tall they were precisely. My best guess would be, I'd be the least wrong, that's a way of putting it, if I guessed 62.5. So, I've drawn a graph here. We've seen this kind of thing before. A graph where and this incidentally is referred to as a histogram, where on the vertical axis, I've got the absolute frequency, and on the horizontal axis, I've got the various heights. I can show it a little bit more clearly like this. You can see now that 56.5 represents the midpoint value, reflecting the fact that this is, the height in inches is a continuous variable. And I could spread this out so it becomes truly what would be a histogram. So it's a continuous shape, if you will. I can introduce a new concept, and this is one we'll be using in this particular lecture, the idea of relative frequency. What this refers to is really just the proportion of students that fall into a specific category. Let's take a look at this. If, for example, I say there were 2 students of 200, the total, then that would be, 1%. You can see it as 2 divided by 200, so it's 0.01. The next group, there's going to be 20 of them of 200, so that would be 10%, or in decimal form, 0.10. Here I've got the different categories of cells referred to as K. So I've got midpoint value for K, and then the absolute frequency for K, and then absolute frequency divided by relative frequency gives me the absolute frequency divided by the sample size 200 gives me the relative frequency, and so on and so forth. I keep going. 74, it's going to be 0.37, 0.36, 0.14, and 2. Now, if I add the relative frequency together, if I do it correctly, it should come out to be 1. Adding the absolute frequency gives me the total number of students in the sample, which was 200. You'll notice now I've drawn the exact same graph as I had a moment ago, except now I put on the vertical axis the relative frequency, which is going to be the shape of the curve is the same as absolute frequency. We've just changed the vertical axis. Very quickly now we can see the mode. The mode is the most common height. That is the women between 61 and 64 inches. And if I had to pick a number for this, this would be 62.5. You can see it's the mode because it's the most common one. In this case, it's 37%, or the highest on the graph, histogram graph. Now, let's calculate the weighted mean, which is the point of the exercise. Watch how I'm going to do this. I take the midpoint value, 56.5, and I'm going to multiply it by the relative frequency, 0.01. And that gives me this number, 0.565. This final column, does it have a name? Well, it's simply the midpoint value multiplied by the relative frequency. Let's do another one. 59.5 times 0.10, and that gives me 5.95. I can do the next one. You can verify with a calculator if you want these numbers. Easy to do with Excel. So once again, I'm taking the midpoint value, multiplying by the relative frequency, and so on and so forth. And when I add all of these numbers together, I get this number, 64.24, which is the sample mean or the weighted mean, which I indicate as X with a bar on top. I want to take a quick glance at what this calculation amounts to really. If I were to do it the simple method as before, well, in effect, what would happen is I'd have two students that were 56.5 inches tall. Then I'd have 20 students that were 59.5 and 74 students and 72 and so forth. I would multiply this and then divide by 200, and that would give me the average. That would be the simple method. Taking into account the fact that I don't know exactly how tall each of the students is, my best guess is the midpoint value. Now, I can rearrange this arithmetic a little bit and just do it this way. I can divide by 200 for each case, divide before dividing by 200 at the end. So I've done this again this way. And in effect, this amounts to 56.5 times 0.01, and which is simply what we've done in the table above. So in effect, the calculations are identical, really, with the exception maybe in the case of the simple method, we have the exact numbers, where in the case of a continuous variable like heights, for example, we don't have the exact numbers. Another way to use this summation notation is you'll see that what I'm doing here is multiplying the midpoint value here times the relative the relative frequency. I want to take a look at how we'd go about calculating the median. Well, the median is going to be the person, if you line up all 200 women, I'd have to walk down the line, find the 100th person, 101st person, and ask them how tall they are. And in fact, I'm going to do that here with the notion of relative frequency. Now notice relative frequency, what I've done here is I've taken this number here, added it to this number, it gives me this number. Then I take this number, add it to this number, it gives me this number. Take this number, add it to this number. So this cumulative frequency is just simply adding up the numbers as we go down the list. And you can quickly see here that 0.48 is the 48th percentile, the 48% of the people. We haven't crossed over the 50th. That's going to happen in the next group here, where the median then would be 65.5, because that's where somewhere in that group we're going to be crossing over to be the 50th person. 50th percent, 96, 97, 98, 99th person. It probably is this median is probably going to be closer to 64. That's likely. But if we were to report it, we'd report it as 65.5 because that's the best guess that we've got, midpoint value of that particular group. I can do this in a slightly different way, where I'm going to now graph the cumulative frequency. In effect, what I've done here is the relative frequency, this is this chart here, and now this series of numbers as I've charted down here. You'll notice, of course, with the cumulative frequency, it's always going to get bigger because we're adding the numbers as we go along. In this case, we can see the median is by 0.5 here, which shows clearly that this is going to be the median group in this section here, because this is where we cross over the 50th, well, the 100th person halfway through the group. We know that half the students are shorter than the median, another half are taller than the median, and our guess for that is going to be around 65.5 or so.